Sir John Rennie, the master bridge builder of London. London, an ever-evolving metropolis where history intertwines with modernity. As we glide along the Thames, approaching the iconic London Bridge, we witness a panorama that is both breathtaking and unparalleled. The view is dominated by a series of magnificent bridges, 15 within a mere 4-mile stretch, each bearing the weight of the city's ceaseless tide of humanity. Amidst the labyrinth of steamers, barges, and skiffs navigating the river and the relentless flow of pedestrians and vehicles above, one name stands out in shaping this urban tapestry: Sir John Rennie, the master engineer whose genius gifted London some of its most enduring bridges. Sir John Rennie, 1794 to 1874, was not merely an engineer, he was an innovator who redefined bridge construction during the Industrial Revolution. His contributions transformed London's infrastructure, leaving a legacy that continues to support the city's growth and vitality. Today, we delve deep into the life and works of Rennie, exploring the technical brilliance and visionary foresight that cemented his place among engineering's elite. Born into a lineage of engineers, Rennie inherited a profound heritage. His father, John Rennie the Elder, 1761 to 1821, was a preeminent engineer whose works included the Kennet and Avon Canal and the original Waterloo Bridge. The Rennie family's roots trace back to the reign of Charles II, with their involvement in a Scottish firm of machinists and millwrights established in the late 17th century. This deep-seated tradition in practical mechanics profoundly influenced Rennie's upbringing and education. The emphasis on hands-on experience was integral to the Rennie ethos. This approach ensured that theoretical knowledge was always grounded in practical application, a philosophy that would shape Rennie's future contributions to engineering. Rennie's education was a masterful blend of theory and practice, designed to produce an engineer of exceptional caliber. Academically, he was mentored by none other than Professor Joseph Black at the University of Edinburgh, a luminary in the field of chemistry and physics. Under Black's tutelage, Rennie honed his analytical skills, delving into the principles of mechanics, thermodynamics, and structural analysis. Concurrently, Rennie apprenticed under Andrew Michael, a pioneer in mechanical engineering known for inventing the threshing machine. This apprenticeship immersed Rennie in the practicalities of machinery, materials, and fabrication techniques. This fusion of rigorous academic study with intensive practical training was a hallmark of the Rennie educational model. It cultivated engineers who were not only theoretically proficient, but also adept at solving real-world engineering challenges. Upon completing his foundational education, a pivotal decision awaited. Should Rennie continue in academia or immerse himself directly in the engineering profession? Guided by his father's philosophy that true engineering mastery arises from direct engagement with practical mechanics, Rennie eschewed prolonged university study in favor of hands-on experience. His father asserted that engineering acumen could not be acquired solely through lectures and theoretical discourse. Instead, it required immersion in realities, materials, tools, labor, and the complex dynamics of project execution. Adopting a rigorous schedule, Rennie worked 8 hours daily on the practical aspects of engineering, dedicating an additional 4 hours to studying science and modern languages. This demanding regimen was instrumental in developing both his technical skills and intellectual breadth. By the age of 19, Rennie was entrusted with significant responsibilities, an uncommon feat underscoring his exceptional capability. As an assistant to the resident engineer of Waterloo Bridge, he gained invaluable experience managing complex engineering tasks. Waterloo Bridge, often referred to as the Bridge of Magnificent Proportions, was a project of immense scale and prestige. Shortly thereafter, Rennie undertook daily supervision of the Southwark Bridge's construction. This role required not only technical expertise, but also leadership acumen to coordinate the efforts of a diverse workforce. The Southwark Bridge, an engineering marvel. Completed in 1819, the Southwark Bridge stood as a testament to engineering prowess. Spanning the Thames with 3 cast-iron arches, the central arch stretching an impressive 240 feet, it was the largest cast-iron arch bridge of its time. The bridge's foundations plunged into a river depth of 36 feet at high tide. a formidable challenge requiring innovative solutions to ensure stability and durability. Costing £800,000, equivalent to approximately £70 million today, the bridge's construction over 5 years showcased advanced techniques in ironwork and masonry. Rennie's innovative methods included the transportation and placement of massive stone blocks weighing up to 25 tons. These feats were achieved through the design of special machinery and logistical planning, reflecting his ingenuity and meticulous attention to detail. Engineers lauded the Southwark Bridge for its architectural simplicity and the massive character of its details, elements that contributed to both its aesthetic appeal and structural integrity. Recognizing the importance of global perspectives in engineering, Rennie's father arranged for him to embark on a comprehensive study tour. Over 2 years, Rennie traversed Europe, visiting France, Italy, Greece, and Egypt. He studied ancient structures such as the Pont du Gard and Roman aqueducts, analyzing their construction techniques and longevity. Rennie extended his travels to parts of Asia Minor, examining engineering practices across cultures and epochs. This exposure enriched his understanding of materials, structural forms, and the integration of engineering within societal contexts. This grand tour not only broadened Rennie's technical expertise, but also inspired a holistic approach to engineering, one that considered historical lessons and global innovations. In 1821, the untimely death of John Rennie the Elder thrust the 27-year-old Sir John Rennie into the forefront of British engineering. He inherited the responsibility of completing his father's projects, including the new London Bridge, a task that demanded both respect for established methods and the confidence to implement new ideas. Rennie balanced tradition with innovation, ensuring continuity while adapting to emerging technologies and methodologies. His leadership solidified the Rennie legacy as he upheld the highest standards of engineering excellence. Under his direction, the firm continued to influence infrastructure development across Great Britain, contributing to canals, docks, and harbors that supported the nation's industrial expansion. London Bridge had spanned the Thames since 928 AD, with various iterations serving the city over the centuries. By the early 19th century, the existing bridge, laden with houses and suffering structural decay, was ill-suited for modern demands. Recognizing the necessity for a new bridge that could accommodate increasing traffic and facilitate river navigation, Rennie's father had proposed a replacement. In 1824, after a competitive selection process involving 30 firms, the contract was awarded to the Rennie firm. The design called for a bridge 920 feet in length, comprising 5 granite arches with spans ranging from 130 to 152 feet. The construction employed cutting-edge techniques such as cofferdam foundations and precise stone masonry. Rennie's meticulous attention to minimizing river obstructions resulted in improved tidal flow and navigation. Opened by King William IV in 1831, the new London Bridge became a vital artery, handling an unprecedented volume of traffic, estimated at over 25,000 vehicles and countless pedestrians daily. The bridge stood as a paragon of engineering, combining functionality with understated elegance. Its design reflected an optimal use of materials with not an atom of superfluous material, showcasing efficiency without compromising strength. Sir John Rennie's contributions were formally recognized when he was knighted during the bridge's opening ceremony, a testament to his impact on British infrastructure. Recognition and further achievements. Beyond London, Rennie extended his expertise internationally, contributing to the burgeoning field of railway engineering. In Portugal and Sweden, he oversaw the construction of critical railway lines, adapting his knowledge to diverse geographical and technical challenges. Rennie observed the explosive growth in engineering during the railway boom of the 1840s. He noted the influx of individuals entering the profession without adequate training, a phenomenon that led to innumerable blunders and reckless expenditure of resources. His insights highlighted the importance of comprehensive education and the dangers of diluting professional standards in the face of rapid industrialization. Reflections on engineering education and practice. Rennie's experiences underscored the critical need for rigorous training in engineering, a discipline requiring precision, foresight, and a deep understanding of both theory and application. He lamented the trend of amateurs entering the field, emphasizing that engineering achievements were not the result of happenstance but of meticulous planning and execution. Rennie advocated for educational models that integrated theoretical instruction with practical experience, a conviction rooted in his own upbringing. His reflections serve as timeless advice for aspiring engineers: dedication to continual learning, honing of practical skills, and adherence to the highest ethical and professional standards. Legacy in final years. In his later years, Sir John Rennie dedicated himself to documenting his vast experiences. His autobiography of Sir John Rennie, published posthumously in 1875, offers invaluable insights into the evolution of engineering during a transformative era. Known for his considerate leadership, Rennie fostered loyalty and excellence among his collaborators. His attention to the welfare and development of his team contributed to the successful completion of complex projects. Passing away in 1874 at the age of 80, Rennie's legacy endures not only in the physical structures he created, but also in the principles he espoused: integrity, innovation, and a commitment to advancing the field of engineering. Sir John Rennie's profound impact on London's infrastructure is a testament to his engineering mastery. His bridges, magnificent in both form and function, continue to serve as vital components of the city's architecture. His life exemplifies the fusion of theoretical knowledge and practical skill, setting standards that have shaped modern engineering practices. As we look to the future, Rennie's legacy inspires us to pursue excellence, embrace innovation, and recognize the enduring importance of engineering in building societies.